Hello everyone, good morning. I am Nikunj, your physics teacher from QNI, and I welcome you all to the QNI class. How are you all? Good morning everyone. Am I audible? Please confirm. Okay, so before starting the lecture, what we are going to study today? Today we are going to study the lecture about motion, but what are the prerequisites? So first one is your basic mathematics, then distance and displacement, and speed and velocity. So these are the prerequisites for this chapter. And if we talk about the weightage, so approximately 7 to 8 marks question asked from this chapter. Okay, approximately 7 to 8 marks question asked from this chapter. And what we are going to study today. So first we will see what is acceleration, types of acceleration, and based on this we will solve some questions also. Okay, so now we will see what is acceleration. But before starting the lecture, let me give you a quick recap. In the last class, we were discussing about average speed and average velocity. Before that, speed and velocity. Okay, what is uniform motion? What is non-uniform motion? So first, what is uniform motion? When a body is covering equal distance in equal interval of time, that is uniform motion. Okay, and what is non-uniform motion? When body is covering unequal distance in equal interval of time is non-uniform motion. Now, what is speed? So how fast or how slow you can cover any distance in a time is called speed. And what is velocity? Velocity is displacement upon time. Now, distance is a scalar quantity, speed is also a scalar quantity. Displacement is a vector quantity, velocity is also a vector quantity. Now, what is average speed? So, total distance upon time taken is average speed. And what is average velocity? So, total displacement upon time taken is average velocity. Now, based on this, we solve some cases also. In the first case, if distance and distance and time is given, so average speed is total distance upon total time. Okay, and what is if second case, let's say distance given and speed are given. In the next case, let's say speed and given and distance is given. So these are the three cases we solved in the last class. Okay, now we'll start with the lecture acceleration. Okay, so what is acceleration? So rate of change of velocity is called acceleration. Okay, so acceleration. Now how you can accelerate? So there is accelerator in the car. Okay, so when you press the accelerator, car speeds up. Yes or no? Okay, so what is acceleration? So acceleration is rate of change of velocity is called acceleration. That means velocity is changing with respect to time. So with time, how fast or how slow velocity is changing, that is given by the acceleration. Okay, now change of velocity means velocity at any time t minus initial velocity. Change in velocity means velocity at any time t minus initial velocity. Okay, is this clear to everyone? Any doubt? Yes or no? Any doubt? Anyone? Okay, very good. So you can see here there is a busy road. Okay, so on a busy road, the velocity of the vehicles changes with respect to time. So we can say the body is in under acceleration. Okay, because velocity here is not constant. Velocity is changing with respect to time. Sometimes speed will increase, sometimes speed will decrease. Okay, sometimes it remains constant. So when speed is constant, we can say there is no acceleration. But when speed is changing with respect to time, either speed is increasing or decreasing, we can say there is a acceleration. Okay, suppose on a straight road, let's say body is starting from x is equals to 0. Let's say initially body is going towards right. That means speed of the body is towards right, and also the acceleration is acting towards right. Okay, so here can we say that acceleration is supporting the motion? Yes or no? And if acceleration is supporting the motion, that means speed will increase. Yes or no? Now, in the next case, let's say body is going towards left. Okay. And again, acceleration is also acting towards left. In this case also, acceleration is supporting the motion. That means speed will increase, but in the opposite direction. Suppose I am taking right side as positive, left side as negative. So in the first case, we can say that speed is increasing towards positive side, and in the next case, we can say the speed is increasing towards left or on the negative side. Okay, but what will happen? Suppose again there is the same body going towards right, but in this case, acceleration is acting towards left. So in this case, we can say acceleration is not supporting the motion, acceleration is opposing the motion. So in this case, we can say that speed of body will decrease. Yes or no? Similarly, let's say body is going towards left and acceleration is acting towards right. Now, in this case also, acceleration is not supporting the motion, it is opposing the motion. So here we can also say that speed will decrease. Okay. For example, you can say, suppose there is a pen, and if I throw a pen in upward direction, so after some time, this pen will stop. Yes or no? After some time, this pen will stop. Now, till the time this pen is going in upward direction, the acceleration is acting in downward direction, because of which as time passes the speed of this pen will decrease, go on decreasing. Yes or no? And at some height it comes to rest for a moment. After that this pen will come in downward direction. Yes or no? And as pen is moving in downward direction, the speed of this pen goes on increasing. Why? Because when this pen is going in upward direction, acceleration is acting because of the gravity in the downward direction. So in the first case, speed of the body is in upward direction and acceleration is acting in downward direction. So in this case, acceleration is opposing the motion. That's why the speed of this pen will go on decrease as it's going up. Okay. And at some height, it will come at a rest for a moment. Okay. Now, when this pen will start coming down, that means speed of this pen is in downward direction and acceleration is also acting in the downward direction. Now, in this case, acceleration is supporting the motion. That means as pen is come down, the speed of this pen will go on increase. Yes or no? Is there any doubt that what is acceleration, how it is supporting the motion, when speed will increase, when speed will decrease? Any doubt to anyone? Yes or no? Is this clear? Yes or no? Any doubt that what is acceleration, how it is supporting the motion, how it is, yes or no, how speed will increase or decrease? Any doubt? Is this clear to everyone? Okay, very good. So the rate of change of velocity is called acceleration. If we see mathematically, so acceleration is nothing but change in velocity upon time. Acceleration is change in velocity upon time. Now change means final velocity minus initial velocity. Okay, change means final velocity minus initial velocity. Now final velocity means velocity of the body at time t, and what is initial velocity? When body is starting its motion. So initial velocity may or may not be zero depending upon the condition. Suppose I drop this pen from a height, so its initial speed is zero. But if I throw this pen in downward direction or in upward direction, so initial speed is not zero. So initial speed may or may not be zero depending upon the conditions. Okay, and what is final velocity? So velocity after time t is final velocity. So what is acceleration? Final velocity minus initial velocity upon time. Okay, suppose if we are denoting acceleration by a and initial velocity by u, okay, acceleration by a, initial velocity by u, and final velocity by v, time by t. So if we see the mathematical formula, so acceleration is change in velocity, that is final velocity minus initial velocity. Okay, final velocity minus initial velocity upon time. So a is equals to v minus u by t. Okay, v minus u is change in velocity and t is time. So change in velocity with respect to time is nothing but acceleration. Okay, now if we talk about the unit, so SI unit or MKS system of unit of acceleration is, now unit of speed or velocity is meter per second. Okay, now time is second. So meter per second is meter per second square. Similarly, in CGS system, it is centimeter per second, which is centimeter per second square. Okay, so SI unit of acceleration is meter per second square, and CGS system of unit is centimeter per second square. Okay, any doubt? Anyone? Any doubt? Yes or no? Is this clear to everyone? Okay, very good. Now we will see types of acceleration. So basically there are three types of acceleration: positive, negative, and zero. Now here I told you that if acceleration is supporting the motion, so in this case speed will increase, and if acceleration is opposing the motion, in this case speed will decrease. Okay, so remember this point. So what is positive acceleration? Now if speed of the body will increase, that means acceleration is positive, that means acceleration is supporting the motion. For example, plane is taking off, so initially plane is at rest. Okay, but as it take off, its velocity will increase, and if velocity is increasing, that means acceleration is supporting the motion, and if acceleration is supporting the motion, we say acceleration is positive. Okay, now what is negative acceleration? So as plane is landing, its velocity go down, decrease, that means we can say plane is under retardation or plane is deaccelerating. That means here acceleration is opposing the motion, that means speed will decrease. And what is the meaning of zero acceleration? That means there is no acceleration. Now if a body is moving with constant speed means there is no change, and if there is no change in velocity, so initial velocity minus final velocity or final velocity minus initial velocity is zero. So acceleration is zero. That means if acceleration is zero, speed will remain constant, velocity will remain constant. Yes or no? Any doubt in positive, negative, and zero acceleration? What is the meaning of positive acceleration? If velocity is increasing, that means acceleration is positive. If velocity is decreasing, that means acceleration is negative or acceleration is opposing the motion. And if velocity is constant or speed is constant, we can say acceleration is zero. Any doubt? Yes or no? Okay, very good. So tell me the answer. A car is starting from rest and moving is an example of positive acceleration. Okay, clear? Because if car is starting from rest, that means initial speed is zero, and it starts moving, that means its speed is increased. And if speed is increased, that means there is a positive acceleration. Yes or no? That means acceleration is supporting the motion. So answer is A, positive acceleration. Clear? Very good. Now, second question. The distance traveled by a body in a given direction in unit time is called velocity, speed, velocity or speed, D, acceleration. Tell me. Distance traveled by a body in a given direction in unit time. Okay. A. Any other answer? Velocity or speed, acceleration. Question is saying about distance, not displacement. And distance is a scalar quantity. Distance is a scalar quantity. So distance traveled in a given direction in unit time. Can we, how many of saying option can we see? Because direction is fixed there. If body is traveling in a straight line without changing the direction, that means in a specified direction, in that case, can we say that distance is equal to displacement? Yes or no? Option D is incorrect. Why? Because distance or displacement per unit time is called velocity or speed. Acceleration is change in velocity per unit time. So option D is wrong. Okay. Either option A is correct, B is correct, or C is correct. Now tell me, when distance is equal to displacement, when body is traveling in a straight line without changing the direction, or you can say distance traveled by a body in a given direction. Yes or no? So can we say that in this case distance is equal to displacement? Yes or no? Can we say distance is equal to displacement? Yes or no? Okay. So in this case, can we say if distance is equal to displacement, so distance or displacement here per unit time is velocity or speed? Yes or no? Is this clear to everyone or any doubt? Okay, very good. Now tell me this question. Which of the following statement is correct? Units of speed and velocity are different. B option, unit of velocity and acceleration are same. C option, unit of speed and velocity are same. D option, unit of speed and velocity are same only in MKS system. So which option is correct? A, B, C or D? Which option is correct? Okay, and I saying D. Okay, and okay, option C. Any other answer? C. Okay, good. B, unit of velocity and acceleration are same. Okay, okay. Now, what is the speed? Speed is distance upon time. Okay, so unit of speed in SI system of unit is meter per second. But in CGS, SI or you can say MKS. Okay, but in CGS, length is measured in centimeter and time in second. So unit is centimeter per second. Okay, now if we talk about velocity, so again, velocity is displacement upon time. Now, what is displacement? Unit of displacement is meter. Time is second in MK system. Yes or no? Okay, very good, very good. So in SI or MK system of unit of velocity is meter per second. Okay, but in CGS, again, length is measured in centimeter and time in second. So you can say in both system of unit SI or MKS, unit of speed and velocity are same. So option D is incorrect. It is saying that unit of speed and velocity are same only in MKS. No, this is wrong. Unit of speed and velocity is same in all system of unit, whether it is MKS, SI, CGS, FPS, any system of unit. Okay. Now option C, unit of speed and velocity are same. This is correct. Now unit of velocity and acceleration are same. Now acceleration is change in velocity with respect to time. Now unit of velocity is meter per second and unit of time is second. So unit of acceleration is meter per second square, but unit of velocity is meter per second. So this is not same. Okay, so unit of velocity are different, not same. So this option is also incorrect. Now A option, unit of speed and velocity are different. No, unit of speed and velocity are same, which is meter per second. So option A is also incorrect. So correct option is option C. Very good. Many of you are correct. Very good. Now solve this question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Everyone solve this question. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Use the formula for acceleration, that is change in velocity with respect to time, or change in speed with respect to time. What is the answer? Given initial speed, here in the question given initial speed, let's say u is equals to 80 kilometer per hour. Okay, final speed, let's say v given as 60 kilometer per hour, and time given is time, let's say t given 5 seconds. 4, please take care of the units. Unit of speed is in 80 kilometer per hour and time is in second. So convert the unit, either convert second into hour or convert hour into second. In numerator and denominator. Okay, minus 10 by 9, 4. Okay, okay. First tell me, acceleration here is negative or positive? Acceleration here, negative or positive? Negative or positive? Good. Okay. So here acceleration is negative. Why? Because speed of bus is decreasing from 80 to 60. That means here acceleration is not supporting the motion, it is opposing the motion. So answer will come in negative. Okay, very good. Okay. So now we will use the formula that acceleration is change in velocity, that is final velocity minus initial velocity upon t. Okay. Now given 80 kilometer per hour. Now how we will convert kilometer per hour into meter per second? Tell me. We know that in 1 kilometer we have 1000 meter and 1 hour is equals to 3600 second. Yes or no? So 100 cancels out. So 2 into 5, 2 into 18. That means 1 kilometer per hour is equals to 5 by 18 meter per second. Yes or no? Any doubt? Okay. So we can write here that 80 into 5 by 18 meter per second. Similarly, we can write here 60 into 60 into 5 by 18 meter per second. Okay. Now given final speed is 60 into 5 by 18 minus initial 80 into 5 by 18 upon time given is 5 seconds. Okay. So we always solve the problem in SI or MK system of unit until mentioned in the question. Okay. If in question it is asked that what is acceleration in kilometer per hour square. Okay. So you can convert units in kilometer per hour. But if nothing is given in the question, we will always solve the question in SI or MK system of units. Okay. Very good. Now this is equals to 60 into 5 by 18 minus 80 into 5 by 18. We can take 5 by 18 common. Okay. So 5 by 18 into 5. Now 60 minus 80. Yes or no? So this is equals to minus 20 into 5 upon 18 into 5. 5 and 5 cancels out. So 2 into 10, 2 into 9. So the acceleration is minus 10 by 9 meter per second square. So how many of are correct? Minus 10 by 9. Okay, Rudra Pratap, very good. Shubhranshu, very good. Any doubt to anyone in this question? That acceleration is minus 10 by 9. Yes or no? Any doubt or this question clear to you? Yes or no? Is this clear? Okay, very down. Very good. Now, next, solve this question given. A train starting from a railway station and moving with a uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. Solve this question, everyone. Again, use the same formula that acceleration is change in velocity with respect to time. Again, take care of the units. Here, unit of speed is in kilometer per hour and time is in minutes. Okay, so what is the answer? Acceleration is change in velocity with respect to time. 1 by 54 meter per second square. Okay. Any other answer? Shubhranshu? Okay. Now given train is starting from a railway station. If train is starting from railway station, that means its initial speed is 0. Yes or no? And train attains a speed of 40 km per hour. That means after 10 minutes, speed is 40 km per hour. And time taken to attain this speed is 10 minutes. Okay, so this is equals to time is 10 minutes. Okay, very good. So here we can convert all unit in meter per second. Okay, so this is 40 into 5 by 18 meter per second. Yes or no? Similarly, time is equals to in 1 minute we have 60 seconds. So in 10 minutes we have 10 into 60 seconds. Okay, now put the values. So acceleration is final speed, which is 40 into 5 by 18 minus 0. Okay, into 10 into 60. Okay, so cancel by 10. Now 5 into 2. Now 2 into 2. 2 into 3. So acceleration is 1 by 18 into 3, that is 54. So 1 by 54 meter per second square, and here acceleration is positive. That means speed is increasing, and speed is increasing because initial speed is 0 and after 10 minutes speed is 40 kilometer per hour. Okay, so this is your answer, that acceleration is 1 by 54 meter per second square. Any doubt? Yes or no? Anyone? Any doubt? Okay, very good, very good. Now we'll see types of acceleration. So the first acceleration is uniform acceleration. Similarly, we studied about uniform motion. What is uniform motion? If body is covering equal distance in equal interval of time, so we can say the body is under uniform motion. Similarly, what is uniform acceleration? So if there are equal changes in velocity of a body in equal interval of time, here change in velocity with respect to time is same for all time interval, we can say body is under uniform acceleration. Okay, suppose there's a school bus starting from this point. Okay, now if when it is starting, that means initial speed is 0. Okay, it is starting from rest. Now at 0 time velocity is 0. Okay, so initially speed is 0. Let's say bus is starting from this point and going to this point. Okay, now let's say here speed after 5 seconds is 8 meter per second. Okay, so we make table here. Okay, for different time interval we'll study that what is the velocity of the bus at different time interval. Okay, so let's say again after 5 seconds velocity becomes 16 meter per second. Similarly, we can say after 15 second speed velocity is 24, after 20-second velocity is 32. Okay, now here you can see that difference in time everywhere is same, that is 5 second. Okay, everywhere difference in time is same, that is 5 second, and also the change in velocity for time interval, that is 5 second, is same everywhere. Here 0 to 8 change is 8, 8 to 16 change 8, 16 to 24 again change is 8. Okay, so we can say that body, there are equal change in velocity of a body in equal time interval, so we can say the body is under uniform acceleration. Okay, you can also see here that here the time interval is same everywhere. Okay, See, let's say finally it will, after 35 seconds, it attains a velocity of 56 meter per second. Okay. So you can see here the difference in time between two instants is 5 seconds. Okay. So again, everywhere the difference in time is 5 seconds. Now, if we see the change in velocity after 5 seconds, every time it is 8 meter per second. Okay. So there are equal changes in velocity, that is 8 meter per second. And if there is equal change in velocity, we can say the body is in uniform acceleration. Okay. So we can say the van is moving with uniform acceleration. Is this clear to everyone that what is uniform acceleration? Yes or no? Okay, very good. Now we'll see that what is non-uniform acceleration. Now, anyone, what is non-uniform acceleration? What is non-uniform acceleration? Anyone? What is uniform acceleration? If body is, there are equal change in velocity in equal interval of time, we say body is under uniform acceleration. Now, what is non-uniform acceleration? What is non-uniform motion? First, tell me what is non-uniform motion. If body is covering unequal distance in equal interval of time, we say body is in non-uniform motion. Similarly, what is non-uniform acceleration? Tell me what is non-uniform acceleration. If there are unequal changes in velocity in equal interval of time, we say body is under non-uniform acceleration. Okay. So if there are unequal changes in velocity of a body in equal interval of time, then it possesses non-uniform acceleration. Okay. Again, we make the same table. Let's say again the van is starting from the rest. Okay. So initially at 0 second, we can say velocity of the bus is 0. Okay. So initially that is at 0 second, velocity of the bus is 0. Let's say after some time it reaches to the final point. Okay. And we make the table for different time intervals. Suppose after 5 seconds velocity becomes 7, after 10 seconds velocity is 15, after 15 seconds velocity is 26. So similarly we fill the table. Okay. Now we can see here that everywhere time interval is same, which is of 5 seconds. Okay. Everywhere time interval is same, which is of 5 seconds. So the difference between two instants of time is 5 seconds. Okay. Now if we say, if we see the change in velocity, so everywhere the change is different. In first 5 seconds, change is of 7 meter per second. Again, after 5 seconds, the change is of 8 meter per second. Again, after 5 seconds, change is of 11 meter per second. So there are unequal changes in velocity in equal interval of time. In equal interval of time, there are unequal changes in velocity. That means we can say this van is moving in non-uniform acceleration. Okay. Is this clear? So there are unequal changes in velocity. So the van is moving with non-uniform acceleration. Yes or no? And in the real life, we most of the time moving with non-uniform acceleration. Okay. Yes. Any doubt? Any doubt to anyone? Okay. Very good. So when will you say a body is in uniform acceleration? So when there are equal changes in velocity, equal changes in velocity in equal interval of time. If there are equal changes in velocity in equal interval of time, we say body is under uniform acceleration. Similarly, when we say body is in non-uniform acceleration, when there are unequal changes in velocity in equal interval of time, we say the body is in non-uniform acceleration. Clear? Okay, very good. Now solve this question. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applied brake such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. Everyone solve this question. Okay, Rahul is starting from a stationary position. Okay, that means initially at t equals to 0, u is equals to 0. Now after 30 second, after 30 second, he attains a velocity of 6 meter per second. He attains a velocity of 6 meter per second. Okay. Now, then he apply brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. So here the velocity is 4 meter per second. So let's say here acceleration is a1, here acceleration is a2. Now we have to find the acceleration in both of the cases. So again use the formula that acceleration is change in velocity with respect to time, and everyone please solve this question. That what is acceleration? Done? Yes or no? What is the answer? Okay. So for the first case, that is A1, is change in velocity. So after 30 seconds, speed is 6 meter per second. So we can say that final speed is 6, initial speed is 0, and time taken by the body is 30 seconds. Okay. So the acceleration for the first case is 6 by 30 meter per second square, which is 1 by 5 meter per second square. Okay. But in the second case, that is for A2. So we can write that A2 is equals to change in velocity. Now final velocity is 4 meter per second for this case, and for this case initial speed is 6 meter per second. Okay, so final minus initial, that is 4 minus 6 upon time taken. Now time taken to attain a speed from 6 to 4 is 5 seconds. So time taken by the body is 5. Now this is equals to 4 minus 6 is minus 2 by 5 meter per second square. So here you can say in the second case the acceleration is negative. That means in the second case acceleration is not supporting the motion, it is opposing the motion. That's why speed is decreasing. And if speed is decreasing, acceleration is negative and it comes out negative. Okay. And in the first case, speed is increasing with respect to time. So we can say there is a positive acceleration acting on the body. So speed is increasing with respect to time. So acceleration is positive, which is 1 by 5 meter per second square. Okay. Is this clear to everyone? Any doubt in this question? Anyone? Any doubt in this question? Yes or no? Okay, very good. Now we will conclude today's lecture. So first we studied about acceleration. So what is acceleration? Acceleration is change in velocity, change in velocity with respect to time. Change in velocity with respect to time. Now SI unit of acceleration. What is SI unit of acceleration? It is meter per second square. Okay, you can say SI or you can say MKS, and CGS unit is centimeter per second square. CGS unit is centimeter per second square. Yes or no? Okay, very good. Then we saw about types of acceleration, and we also studied that if acceleration is positive, speed will increase. If acceleration is negative, speed will decrease. And if acceleration is zero, that means body will move with constant speed. Yes or no? Now, if we talk about the types of acceleration, so there are two types of acceleration. Uniform acceleration. First is uniform acceleration, and the second one is non-uniform acceleration. Second one is non-uniform acceleration. Now, what is uniform acceleration? So if body is covering, if there are, we can say if there are equal changes in velocity in equal interval of time, so acceleration is uniform. And if there are unequal changes in velocity in equal interval of time, we say acceleration is non-uniform. Okay, is this clear? Yes or no? And we solve some questions also. Okay, now in the next class we will study about graphs. Okay, so next class is very important because we study about graphs. So relation between velocity time graph, distance time graph, various graphs. Okay, so please attend next lecture because this is very important. Okay, so I hope you enjoyed today's session, you understand well. Okay, so there is a homework at home. Please practice at least 20 questions on the platform from the selected topic. Okay, go on motion chapter, then select the topic and practice for the selected topic. Okay, I will discuss in the next class. Okay, so please practice at least 20 questions on the platform. Okay.